Okay, ladies and gentlemen, today we're going to be talking about comparing numbers that are written in scientific notation. So yesterday we learned that a number in scientific notation has to have three parts. It has to have a number between 1 and 10, but if it's 10, it's too big. It has to have the times 10, and then it has to have some exponent. So what we're going to be doing is when we're comparing them, the first thing that we're going to look for is, do they have the same exponent? Because if the exponent is how big the magnitude of the number, the bigger the exponent, the bigger the number. So when I look at these though, they have the same exponent. So that means I have to then look at the numbers out front. So I'm going to line these up. So 1.815 and how about 1.82? Because what people think a lot of times is, oh, 1.815 has to be bigger, it has more digits. But it's a lot like when you're putting things in alphabetical order and you have to start and you keep comparing until you get things that are different. So here, if I compare these, ones are the same. So then I'm going to look at the next number and I'm going to look here. Well, they both have 8s. That's the same. So then I'm going to look here. I have a 1 and a 2. Well, the 2 is bigger. 2 is bigger than 1. So that means this is the bigger number. So when I write that, I'm going to write it using my inequality symbol. So 1.82 times 10 to the 14th is greater than 1.815 times 10 to the 14th. Now you could flip that. If you wanted to keep it in the order that they gave it to you, we could also say 1.815 is, oops, I forgot the times 10 to the 14th, sorry. Times 10 to the 14th is less than 1.82 times 10 to the 14th. Either way to write it, they're both perfectly the same. They mean the same thing. All right, let's try this next one. So first thing I'm going to look at are my exponents. Well, the exponents are the same. So now I have to look at my numbers out front, and I'm going to line them up, because for me that's easier. If you don't need to do that, that's great. But if you start missing a bunch of them, I'm going to tell you to line them up. So when I compare, right, I'm going to look here first. They both have a 9, so then I have to check over here. They both have a 3, so I have to check over here. Well, this has an 8. This doesn't have anything, which means it's a 0. Well, 8 is bigger than 0. So that means 9.3879 times 10 to the 28th is greater than 9.3 times 10 to the 28th. Again, you could have written it the other way. You could have said that 9.3 times 10 to the 28th is less than 9.3879 times 10 to the 28th. Either way is going to work. All right, let's see here. The Fornax, I hope I'm saying that right, dwarf galaxy is 4.6 times 10 to the 5th light years away from Earth, while Andromeda is 2.43 times 10 to the 6th light years away from Earth, which is closer. Closer means we want the smaller number. So first thing I'm going to check is my exponents. Here we have a 5 and a 6. Two different exponents, which means I can compare my numbers just by using the exponents because we're talking about magnitude. So this number is smaller than this one, which means which one is closer? Fornax, dwarf, is closer. Now I'm going to write a reason. That's supposed to be an X because 4.6 times 10 to the 5th is less than 2.43 times 10 to the 6th. All right, so this tends to be one of the easier topics of this chapter. I hope you're finding that too. Many subatomic particles are unstable. Charged pions, and yes, that is a real word, have an average lifetime of 2.603 times 10 to the negative 8th, while muons, again, yes, it's a real word, have an average lifetime of 2.197 times 10 to the negative 6, which has a longer lifetime, so we want the bigger number. So I'm going to look at my exponents first, And they're different, which means I can use those to compare them. However, these are negatives, so you have to think about your number line, right? Here's my number line. Should have made that a little bigger. So the one that is closer to 0, further to the right, is your -6. So that means that one's bigger. So the muon has a longer lifespan. Because 2.197 times 10 to the -6 is greater than 2.603 times 10 to the -8th. All right, Chris said that 5.3 times 10 to the 41 is less than 5.301 times 10 to the 41 because 5.3 has fewer digits. Show that even though his answer is correct, his reasoning is flawed. Show him an example to illustrate how his reasoning would result in an incorrect answer. So for example, right, so yes, in this case, 5.3 is less than 5.301. But let's say I had made it 5.4 times 10 to the 41st. That is not, that's actually greater than 5.301 times 10 to the 41st. Because if we compare those first digits, they're the same. Then I have to look at the second. 4 is greater than 3. All right, so it's not the digit, how many digits, it's the value of the digits. So summarize the steps for comparing scientific notation. So the first thing we do is we compare the exponents. If they are the same, then we compare the numbers out front. Okay, hopefully you found this one pretty easy today. It's nice to have an easy one every once in a while. But if you still have questions, don't be afraid to bring them to class. Have a good night.